Here we're going to continue another problem in geometric sequences and series. This is a word problem. I've written it out there for you at the bottom. Jasmine's parents invest $4,000 in a registered education savings plan. That's to prepare her for college. And that earns 5% interest every year, compounded annually. That means they put it in at the end of the year. Next year, that's the amount of money you have. So at the end of the first year, you're going to put in this amount. And at the end of the first year, you're going to have this amount times 0.05 added to this amount, which is going to be $200. So after the end of the first year, you're going to have $4,200. And then you're going to, again, at the end of the second year, you're going to multiply, you're going to add this amount, but this time you're going to multiply this by this amount. We'll actually develop a formula for that, and I've written those on this side of the board. What we're going to want to do is find an explicit formula for the value at the end of any year. Find out the first four terms, that is the end of the first year, second, third, and fourth year, and then find out at the end of the 9th, 16th year, and also at what time or how many years does it take to double this initial $4,000 investment. I'm going to erase this scribbling here and take you to the other side of the board. So what we have here is this is a formula for your investment, the value of your investment at the end of any specific time period. That would be $4,000, which is the initial amount, times 1.05. You do 1.05 because if you wanted to, you could break it up this way. It's $4,000 times 1 plus 5 over 100. 5 over 100 would be 5%. That's the meaning of percent. This 1 here gives your original $4,000 back, and then this gives you the growth at the end of the first year. And at the end of the second year, all of this will be contained in your number that you're going to have, which is 4,200. And you're going to multiply again by 1.05, which is what this is. So I've written those formulas up here. At the end of the first year, you're going to have $4,000 times 1.05. Then in the second year, you're going to take this original amount times this. Because, of course, the first time you would have this, and then you would multiply this entire value here by another 1.05 to get the end of the second year. Continue to do the same. That's why your growth that deals with bank value growth or investment growth is often in the form of 1 point something. This would be a percentage. So at the end of the first year, you would have $4,200. The second year, $4,410. Third year this way, and fourth year this way. So here I've calculated the first 4 years just to have it really quickly out of the way. Now, of course, we'll do something very similar for the 9th year and the 16th year. Let me just erase this year and rewrite this here for you. All right, I'm back here. I've written in the investment that you get, the value you get after 9 years. Same thing as before, 4,000 times this to the power 9. Just punch this into your calculator first, 1.05 to the power 9 multiplied by this, and this to the power 16, 6,000 and some, 8,000 and some. Notice here at this point here, we're a little over double, which leads us to our next question, our last question. At what point will this double? Well, we can actually use the same formula, but just have a different part here because we know the answer already. We know it's going to be double. We know it's going to be around 16 years. So let's write out a formula for that. All right, what does it mean for it to double? It means this original amount here is going to have to be $8,000. I mean, the final amount here is going to be up to $8,000. The original amount is $4,000, and you want 1.05 to some value. We don't know what that value is. We know it's going to be less than 16 or in that range. Now we can take both sides, divide by 4,000. We get 2 equals 1.05 to the t. Now all you do is your calculator, you go 1.05 times 1.05 equals, and hit equals over and over again until you get 2 or just over 2. There's a way of doing this exactly with logarithms. We may or may not have covered that in your courses yet, so I'm not going to do it in that method. So just by doing it this way, I'm going to see if I can find a value for t that's very close to some number of years that gives us double the amount. Let me just do the checking on my calculator. I'll be right back. So my calculation shows that if I do this 1.05 and I want to make it close to 2, I'm getting 1.977, just about 2 at the end of 14 years. So we could say roughly at the end of the 14 years, Jasmine will have doubled her investment and she's ready for a year of college, or depending on where you go. I hope that helped with this problem. Check back in the next video. I'm going to do the last one in this section. See you in a minute. Bye.